Not all atoms of an element are exactly the same. For instance, here's an example of a carbon atom in its most common form. Notice that it has 6 protons and 6 neutrons in its nucleus. The fact that it has 6 protons is what makes it an atom of carbon. However, the number of neutrons can vary between individual carbon atoms. These variations are called isotopes. Isotopes are atoms of the same element that differ only in the number of neutrons present in the nucleus. Here's one example of a carbon isotope, carbon-13. Notice that while the number of protons in carbon-13 remains at 6, the number of neutrons has increased from 6 to 7. This gives the carbon atom a slightly higher atomic mass than carbon-12, but chemically, carbon-13 still behaves in the same manner as carbon-12. Another carbon isotope is carbon-14. Carbon-14 has the characteristic 6 protons found in all carbon atoms, but in this case it has 8 neutrons. In some cases, isotopes may be unstable or radioactive. Radioactive atoms emit energy or subatomic particles in order to return to a stable state. This is the case with carbon-14. Radioactive carbon-14 has a number of applications in science. Since carbon is found in all living organisms and the decay rate is well documented, we can use carbon-14 as a way of dating how old a sample of tissue may be by comparing ratios of carbon-12 and carbon-14. Carbon-14 dating is commonly used in forensic studies and in studying archaeological remains.